here comes our third type of discontinuity, and we're going to start talking about infinite discontinuities. And so this happens, so this is going to be in some sense even worse than the previous case. If we have something that looks like this. So here's the axes. So if we have something that looks like this, and we have some vertical asymptote here, our function here is going to have an infinite discontinuity. Let me draw another one, and that illustrates a different side of it. Something that looks like this. It might only have infinite discontinuity on one side. So all of these pictures are examples of functions that have infinite discontinuities. And so the thing that sets these infinite discontinuities apart, but like the big marker here, is if either limit as x goes to c of f of x is equal to infinity, or one of the sides is infinity, or here's the other one, another one side limit is infinity, and really we should be clear, we don't really care if it's plus or minus infinity, so I can stick in pluses or minuses here. So if the limit as you get close to c of f of x is plus infinity or minus infinity, or if you have a one-sided limit, so here the one-sided limit is x goes to 0 from the left is minus infinity, the one-sided limit is x goes to 0 from the right is positive infinity. This is when you have an infinite discontinuity. And so you might wonder, like, when this comes up in real life. Well, a lot of physical phenomena end up involving what are known as inverse square laws. So, for example, one thing has to do with gravitation. So gravitation. So suppose that you are a planet of some kind, you're revolving around the sun, you're wondering what's the force of gravity between you and the sun, and you're wondering how that depends on how far away from the sun you are. So the force would be some constants, where those constants are going to depend on the sun's mass, on you being the planet's mass, there's an overall constant just due to gravity and stuff like that, and all of it divided by r squared. So what this looks like is that as you get really, really close to the sun, well, the distance from the sun keeps getting smaller, 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 and so it goes off to infinity because you're divided by something really, really small there. And so gravitation works this way. Electrical, so force. So you have two electrons or two protons or something like that, two charged particles, and you put them really, really close together. Again, you're going to have this kind of inverse square law with an infinite discontinuity. The book discusses intensity of a light source. So it should be known that this is something that certainly could happen. This is just a model for what happens here. One final type of discontinuity. The book doesn't use this term, so I'll provide it myself here, is an essential discontinuity. And so we've previously have seen one example of essential discontinuity in a previous video. Y is equal to the sine of 1 over x. That's what this should do the trick here. Basically, so sine of 1 over x is going to go between 1 and minus 1, and without really being careful about the scale here, it just starts looking like this. It starts looking like this. So it just oscillates infinitely often as you get closer and closer to 0. This is really, really, really messy here. There's the limits don't exist as you for this function as you get close to 0. This is what we call an essential discontinuity. So far, we've seen in this section all 4 types of discontinuities. So we saw the removal of the discontinuity, which isn't too bad. We've seen the jump discontinuity. We've seen and in this one we've seen the infinite discontinuity and the essential discontinuity, which in some sense these are kind of like the worst possible cases.